utility service to a building is typically not considered a separately derived system. A separately derived system is an electrical power source, such as a generator, transformer, or solar photovoltaic system that has no direct electrical connection to the building's service conductors. The key characteristic of a separately derived system is that it derives its power from a source that is electrically isolated from the main service. This isolation is usually achieved through a transformer where the primary and secondary windings are galvanically isolated, or through other means that prevent a direct current path between the source and the load. Because the utility service is the primary source of power for the building and is directly connected to the building service conductors, it does not meet the criteria for a separately derived system. The grounding and bonding requirements for separately derived systems are different from those for service entrances. A separately derived system typically requires its own grounding electrode system and a bonding jumper connecting the system's grounded conductor to the grounding electrode. This is to ensure that any fault current in the separately derived system has a low impedance path back to the source, facilitating the operation of overcurrent protection devices and minimizing the risk of electric shock. In contrast, the grounding and bonding of a service entrance are governed by specific rules in the National Electrical Code (NEC), designed to ensure the safety and reliability of the building's electrical system. The NEC defines a separately derived system in Article 100 as an electrical source other than a service, having no direct electrical connection to circuit conductors of any other electrical source other than those established by grounding or bonding connections. This definition emphasizes the isolation aspect of separately derived systems. Examples of separately derived systems include generators, transformers, and solar photovoltaic systems. A generator provides power independent of the utility service, and its output is typically isolated from the utility service through a transfer switch. A transformer isolates the primary voltage from the secondary voltage, creating a new voltage level that is suitable for the load. A solar photovoltaic system generates electricity from sunlight and is often connected to the building's electrical system through an inverter, which may or may not provide electrical isolation. The NEC provides specific rules for the installation and grounding of separately derived systems in Article 250.30. These rules address the sizing of grounding electrodes, the bonding of metal enclosures, and the connection of the grounded conductor to the grounding electrode. The purpose of these rules is to ensure that separately derived systems are installed safely and that they do not create a hazard for people or property. When installing a separately derived system, it is important to consider the following factors. Firstly, the type of separately derived system, such as a generator, transformer, or solar photovoltaic system. Secondly, the voltage and current ratings of the system. Thirdly, the grounding and bonding requirements specified in the NEC. Fourthly, the coordination of overcurrent protection devices. Fifthly, the impact on the building's electrical system. Transformers are a common type of separately derived system used to step down or step up voltage levels. For example, a transformer may be used to step down a 480 volt service to 208 volts or 120 volts for lighting and appliance circuits. When a transformer is used as a separately derived system, it is important to ensure that the secondary side of the transformer is properly grounded and bonded. The NEC requires that the grounded conductor of the separately derived system be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized according to NEC Table 250.66 based on the size of the service entrance conductors. The NEC also requires that all metal enclosures and equipment associated with the separately derived system be bonded together to create a low impedance path for fault current. This bonding is typically accomplished by connecting a bonding jumper between the metal enclosures and the grounding electrode system. Generators are another common type of separately derived system used to provide backup power during a power outage. Generators are typically connected to the building's electrical system through a transfer switch, which allows the generator to be isolated from the utility service when it is operating. When a generator is used as a separately derived system, it is important to ensure that the generator is properly grounded and bonded. The NEC requires that the generator's frame be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized according to NEC table 250.66 based on the size of the generator's output conductors. The NEC also requires that all metal enclosures and equipment associated with the generator be bonded together to create a low impedance path for fault current. Solar photovoltaic systems are becoming increasingly popular as a source of renewable energy. Solar photovoltaic systems generate electricity from sunlight and are often connected to the building's electrical system through an inverter. The inverter converts the direct current, DC, electricity produced by the solar panels into alternating current, AC, electricity that can be used by the building. When a solar photovoltaic system is used as a separately derived system, it is important to ensure that the system is properly grounded and bonded. The NEC requires that the grounded conductor of the solar photovoltaic system be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized according to NEC table 250.166 based on the size of the solar photovoltaic system's output conductors. The NEC also requires that all metal enclosures and equipment associated with the solar photovoltaic system be bonded together to create a low impedance path for fault current. In summary, a utility service to a building is not considered a separately derived system because it is the primary source of power and is directly connected to the building's service conductors. Separately derived systems, such as generators, transformers, and solar photovoltaic systems, are electrically isolated from the main service and have their own grounding and bonding requirements. When installing a separately derived system, it is important to follow the rules in the NEC to ensure that the system is installed safely and that it does not create a hazard for people or property. This typically involves ensuring that the grounded conductor of the separately derived system is connected to a grounding electrode, sizing the grounding electrode conductor according to NEC table 250.66 or 250.166, and bonding all metal enclosures and equipment associated with the separately derived system together to create a low impedance path for fault current. Understanding the difference between a utility service and a separately derived system is crucial for ensuring the safe and reliable operation of a building's electrical system. Consulting with a qualified electrical contractor is recommended to ensure compliance with all applicable codes and standards. The proper installation and maintenance of electrical systems are essential for protecting people and property from electrical hazards. The NEC provides detailed guidance on the installation and grounding of electrical systems, and it is important to follow these guidelines to ensure the safety of the electrical system. In addition to the NEC, local codes and regulations may also apply to the installation of electrical systems. It is important to check with the local authorities to determine the specific requirements for electrical installations in your area. By following the codes and standards and consulting with qualified professionals, you can ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. In electrical engineering, a system is considered separately derived when it meets specific criteria outlined in the NEC. Separately derived systems are typically characterized by having their own independent grounding and bonding infrastructure, distinct from the main service. This is because the system derives its power from a source that is electrically isolated from the primary service. This electrical isolation is usually achieved through a transformer or other means that prevent a direct current path between the source and the load. When a separately derived system is used, it is essential to establish a separate grounding electrode system for that system. This grounding electrode system typically includes a grounding electrode, such as a ground rod, a ground ring, or a connection to a metal water pipe. The size of the grounding electrode conductor is determined based on the size of the separately derived system's conductors, as specified in the NEC. Furthermore, all metal enclosures and equipment associated with the separately derived system must be bonded together to create a low impedance path for fault current. This bonding is typically accomplished by connecting a bonding jumper between the metal enclosures and the grounding electrode system. The NEC provides detailed requirements for the grounding and bonding of separately derived systems, and it is important to follow these requirements carefully to ensure the safety and reliability of the electrical system.